we're going to talk a little bit about oxy-fuel welding and the equipment that we are going to use. It's a little bit different than shielded metal arc welding. With oxy-fuel welding, sometimes referred to as oxyacetylene. We'll talk about the differences later on in this PowerPoint. The equipment is pretty basic. This stuff is actually fairly cheap to acquire. It's a very easy system to do, and it's not nearly as expensive as some of the inverter type welders that we get and all that kind of stuff. There's basic components. You're going to have two different types of tanks. You're going to have some sort of fuel, which most of the time you're going to see is going to be an acetylene, as we can kind of see here, and we're going to have an oxygen tank. We need to have some regulators that are on top of those things, hoses that attach it, and then a torch body with an attachment on there. Could be a cutting attachment, could be a welding attachment, could be a heating tip as well. That's basically all you need. There's no electricity needed, no plugging in, which makes oxy-fuel really nice because you can do that without the use of electricity. Sometimes if we're trying to take shield metal arc welding out into the field, we have to have generator welders that are going to provide that, or a long enough extension. With oxy-fuel welding, we don't have that. Traditionally, what's done with oxy-fuel welding is going to be thinner metal. That's especially what we're going to be doing in our class. We're not going to be welding on that thicker metal. It kind of provides a little easier time to weld that thinner gauge metal. But there are different size tips that you can use to weld thicker material if needed. But a lot of times kind of in the industry and what's kind of done, we don't really use that a whole lot for that. Gas welding still is used. There are some people that tend to not teach gas welding because they say that it's a dying art, but it is still used in, like PG&E and gas lines and things like that. They still do quite a bit of oxy-fuel welding. Cutting attachments, cutting things are going to be basically the same systems. We're going to talk about that a little bit later, but we just put a cutting attachment on. There's a lot of similarities with that, and cutting is still very, very widely used, whether it's using oxy-fuel or plasma, which we're also going to get into plasma a little bit later on. The oxygen valves, we've kind of talked about this in class, but the oxygen valves, one of the important things with these is that the valves are going to be either in the fully closed position or the fully open position. They're designed to withstand high pressures. They have pressures up to about 2,400 psi, somewhere in that range, so it's a lot of pressure. The tanks are made from steel, typically a 1/4-inch steel, so they're pretty strong and they're pretty durable. They can handle that. But the valves, when they seal, they either are going to seal at the base or they're going to seal at the top, which is why the oxygen valves are very important to open them up all the way so we don't lose oxygen if we only just crack it. Because of the high pressure, it can actually leak by. So they seal at the top, they seal at the bottom. On the oxygen tanks, we also are typically going to have some sort of pressure device or safety system. If the pressure increases within that tank, this little valve will open up and it will let some of the gas out. Sometimes if things are being stored outside, if tanks are in the sun and they're exposed, it heats up the gases and the pressure is going to increase. Much like your tires are going to increase as you start driving, the pressures will typically increase as it heats up. Same thing's going to happen in these tanks. So if they happen to go over the regulator pressure right here, it's going to just pop that valve open. Sometimes you may hear them opening. It's just releasing any excess pressure to make sure that the tank doesn't explode. But otherwise, they're pretty strong, they're pretty durable, and they're going to hold a lot. In our systems, when we're doing oxy-fuel, we actually have a manifold system. So we have tanks that are at the end, and then it feeds lines into there. We call that a manifold system. You are going to have a mainline regulator. This is both true of the oxygen and the acetylene. And then each station is going to have its own regulator for each one of those things. The master regulator controls that pressure. We typically are going to increase that a little bit more so that way we can feed the 12 different units that we have. Each of the tanks should be labeled with what is actually contained on the inside. So if it's oxygen, it should be labeled with oxygen. If it's acetylene, it should be labeled with acetylene. If you ever have a tank that you don't have a label on, do not use it. Don't assume what gas is actually inside of there because you could be mixing and matching different things and it could cause a lot of issues with that. So the tank should be labeled. If they're not, return them to the supplier, wherever you get those things from, so that way you can get them replaced. Acetylene is a gas that is very, very highly flammable. It will actually explode under 30 psi or 30 pounds per square inch, which is not very much. So we have to be very cautious when we're working with these things. Acetylene actually has an acetone inside of the tank to help balance it out. These tanks are typically around 350 when they're fully filled. They're around 350 psi, and that acetone on the inside helps kind of encapsulate the acetone or the acetylene to make sure that it doesn't actually hit that 30 psi. So it's one ways that allows us to actually maintain that pressure. One thing that we have to be concerned with is how much we are drawing from that acetylene tank. We don't want to completely empty that tank in a very, very fast time, because that tank pressure and the acetylene or the acetone that's inside of there can get unbalanced and the tank could potentially explode. They say that 1/7 of the cylinder's capacity should not be reduced per hour. We don't have to worry about this in class because we will put a new tank on there and we may not replace one for the rest of the semester once we get a new one on there. We're not using that much acetylene. We're not drawing those things off, so we are very, very far away from this. But if you were in a high capacity, high use area, those are things that we would want to, be concerned with. Some of that stuff is going to depend on the temperature of the cylinder, how much is remaining in the cylinder, and how many different cylinders are providing the flow. We just use one for our systems, but there are some systems where they link a bunch of them together, and that can help actually lower that capacity or increase the capacity, but lower how much we're drawing off from each individual tank. If the tank is very low, then it's obviously going to be more than 1/7 of that cylinder, but it's the total capacity of the cylinder, not what's actually left in the tank. Fuel gases, whether we're using acetylene, that's the most common one that we use. They need to have a special system in place to make sure that those things don't have a fire or anything coming back into those things. A lot of times what we'll have, especially in a manifold system, you might have the acetylene that will go into a little water tank. We call that a water seal flashback arrestor. The gas goes down from the tank, and then there's a pipe on top of the water where that water level's at, so it's above where that water level's at, that enters into the manifold system. What this does is if there's a fire that happens to get into that piping system, it's going to go down into the water seal, the water flashback arrestor, and the flame will stay on the top, but it will not allow it to go down into the water and then back up into the tank. So there are systems that we have in place to do that. We have regulators, control valves, we have flashback arrestors. They're all over the place. I'll show you some examples of what those things look like later on in this thing. One thing that's really important is that acetylene, we never want it to go above 15 psi. There are red lines on the regulators that indicate that you should not ever place it above there. In both our systems, whether we're doing cutting or whether we're doing welding, the pressure that we're going to be setting those things at is 5 psi on the acetylene. In our manifold system, we typically will set it to about 12 or 13, which is still under that 15 psi, but that's to allow the 12 different stations to be fed with the 5 psi that you need to run each of those things. If we just ran the main regulator at 5 psi, if everybody was running each one of those stations, you would not have that 5 psi at each of the stations. So we have to increase it a little bit. It is pretty explosive. Acetylene can, explode, like I said, under 30 psi. So we cut that in half and we set it to a maximum of 15. But when we're actually welding and cutting, we set it to 5 psi. We have smelt that stuff in class. If you haven't smelt that, I will make sure that you do smell that stuff. Acetylene has a very distinct smell. They do that so that way if you smell that, you know exactly what that is, and we need to look at that and find out what's leaking or what was left on, and get that shut off or get it fixed if we need to. If you have too much acetylene, and breathing in a little bit of it is not a problem, but if you have a lot of acetylene, it can actually displace air in a poorly ventilated area. So if you're inside of a tank or inside of a closed, area, you want to be very careful about that acetylene because it's heavier than air and it can displace that and then cause you to suffocate. We're not going to be welding in anything that is not well ventilated. We're not welding inside of anything or cutting or doing any of that stuff. So the chance or likelihood of that happening to us is very slim. But if you're ever in an area that is confined, you need to be careful about that. How these regulators work, they're going to be a little bit different. This one happens to be an oxygen one. The acetylenes are going to be pretty much the same. They're typically going to have some red. The gauges might be slightly different PSIs on these things because we're working at lower pressures on them. But the way these things work, you have the regulator connection that goes here. Your hoses are going to attach to this part. You've got two different regulators on here. This is going to be on the main tanks, where we're going to have our pressure within our cylinder, and then we're going to have our working pressure or our line pressure is going to be right here on the left-hand side. Again, those are going to vary. If it's acetylene, the number is going to be a little bit different, but the process is still the same, where you have tank pressure and then working pressure. At each of your individual stations, you may have only one gauge on them. That gauge is simply going to tell you line pressure because we already have a regulator or a tank pressure on there. Some of them may have two of them, but a lot of them only are going to have one. That is simply just going to be this gauge right here that's telling us our working pressure. To adjust that pressure and to increase it to the desired amount, you have the adjusting screw that's going to be in the center. You turn it clockwise. I guess I go clockwise like this. I'm backwards. You go clockwise to actually increase the pressure, and then counterclockwise to back it off. When we are done welding, you turn it counterclockwise a couple turns to back that off and get that gauge back down to 0. We don't want to leave any oxygen or acetylene in these lines when we are done welding. Those things can cause, oxygen can cause a flame to get bigger. Acetylene is a flammable object. We want to completely remove that and store those only in the tanks when we are done. Some things we talked about in class, but we're going to reference it again. The different hoses are going to be colored. Oxygen hoses are going to be colored green. They might also often be marked with OXY, indicating that they are going to be used for oxygen. They are going to be traditional right-handed threads. To help make sure that we don't mix these things up and we don't mix regulators up, on acetylene regulators or fuel regulators, we're going to be using left-handed threads. So they're actually going to go opposite. So it eliminates the possibility of us actually being able to connect an acetylene hose onto an oxygen regulator or vice versa. Typically, these things are going to be marked with ACE, and they will also sometimes have notches in the threads or on the fittings to indicate that they are left-handed threads. So that way we can see that and know that we don't need to mix those things up. The hoses, we have to be careful with those things, especially the hoses that are coming off on each individual torch. If they come in contact with a flame or they become in contact with hot metal, they can melt and expose that gas out into the environment. We want to make sure that we're not kinked. That can provide with less flow. It can also weaken the hoses and cause them to break down prematurely. During welding, hoses should be protected from falling objects, vehicles, foot traffic. We don't want to step on them, roll over them. We don't want to do that kind of stuff. We got to be careful. At the welding stations, there are tubes that the hoses run down on top of the table that helps protect that, and then it runs underneath that table. The table is also going to provide some protection. The hoses are in pretty good condition, and they are not exposed to a lot of those things. When we're cutting with the oxygen tanks, those things are a little bit more exposed. We have to be careful when using them. The torch bodies that we're going to use, typically we're going to use a positive pressure torch. We basically have a couple different parts. You have the torch tip. This is the welding tip. You have a little nut that you're going to hand thread onto the top of these things. This is where the mixing chamber happens, or where the oxygen and the acetylene mix. Inside of the body is where the lines are actually going to run through, and then we have two different valves on this system to turn on our gases. Our acetylene is always going to be on our left-hand side, and then the oxygen is always going to be the right. You can look at the color of the hoses to help indicate which valve is which gas on those systems. In a positive pressure torch, the oxygen fuels are mixed in the torch and they are burned at the torch tip. That's where we see the flames that are going to come out. The hand valves that we have is used to adjust our gases up or down. So to give us a little bit more acetylene, to give us more oxygen. What we're looking for is trying to reach that neutral flame. We don't want an oxidizing flame, which has too much oxygen. We don't want a carburizing flame, which has too much acetylene. If you haven't seen in class, I will show you in class how we actually set that flame. That is one of the most important parts to oxy-fuel welding. The torch must be of an accurate size. We have different sizes that we use in this class. We are going to be using a double aught, which is 2 zeros, an aught, which is 1 0, and a 1, a number 1 torch. The sizes of those torch as the numbers increase are going to get larger. So for thicker material or to get a hotter weld, you are going to up the size of that nozzle. The welding tips that we are going to use on these things, they are going to vary. We do sometimes have to clean them out. Some of them are a little bit worn out. They are not new tips there. So we have to make sure that we're matching those things. We might have to clean them out. If we do get a flame that's kind of split in two directions, we may have to do that. There are lots of different torch tips. If you're having issues with them, you can swap those things out with another one, or we can try to clean those tips out of any debris that's in there. Some tips are a two-piece system where you have your torch body and then you can actually change the tip there. The ones that we have are just one assembly, so you unscrew this from your torch body. So that's going to unscrew from right here, and then we hand screw or hand tighten a different torch on as we do that. So if we want to swap the tips out, we simply just pull this whole assembly off and we swap it with that. The labels there should be numbers just on the back side of that copper there that's going to indicate the tip size that we're going to be using. Tip cleaners are used to help make sure that we clean it out. If we get debris, we get stuff popping back up into that. It can cause that torch to clog up, and it can cause that flame to become split. It's not going to weld good for you. You're going to have issues with it. A good torch tip is going to help make sure that you actually are welding and get a good weld out of that. They're essentially little round files that go in. You find the file that just barely goes through. You don't want to file that out. You just want to be able to clean those things out. So there are lots of different sizes on the tip cleaners that we're going to use. As far as what we need to wear, the welding helmets that we have are suitable if you use them in a grind mode. You do not need to have them darkened up to a shade 10. Shade 3 to 5 is typically what we are wanting to wear, and the shade 3 is what our welding helmets go to when we set it to grind. There are also glasses, safety glasses that are tinted. They either have a green or a brown, and then there's varying shades that those things can get in. You can purchase a pair if you want instead of wearing the helmet, but the helmets will suffice. The glasses are nice. You don't have to have safety glasses. They are safety glasses built into that, and it's a little bit easier. You don't have to worry about having your face covered with that because we don't have the probability of getting sunburnt like we do or getting that arc flash from those things. We need to protect our eyes, but our face can actually be exposed to those. If you're concerned, wear the welding helmet, and that's going to cover your face from anything that might come back up at you. If you are welding a hood like this or a helmet, you still need to make sure that you maintain safety glasses underneath. These glasses look like they're a little bit shaded there. Those are going to be more like a sunglass. Those aren't going to be a shade that you're going to use for oxy-fuel welding. So if you're using the helmet, make sure you keep the safety glasses underneath. If you have the oxy-fuel shaded lenses, those are literally just safety glasses that are shaded to the correct shade size or shade number, and they're going to provide that stuff for you. We have a couple pairs around in the shop, but again, if you want to get your own, you can. They're not the cheapest safety glasses to get, but they are a little bit nicer to wear. We should have gloves to help make sure that we protect our hands. We are still dealing with heat. Sometimes we will use thinner gloves to get a little bit more dexterity in our fingertips, but the big shielded metal arc welding gloves will still work fine as well. We should try to cover our arms, even though we're not worried about that sunburn. We could have metal coming back at us. We could spark metal. It could pop back at us, and so we want to make sure we wear that. So a lot of the same stuff that we have for shielded metal arc welding should still exist with oxy-fuel welding. When we're lighting the torch, we have strikers that we're going to use which has a flint, and that flint is going to create a spark. That spark is going to help light that torch up. We never want to use a lighter when lighting these things, because if that flame burns or melts that lighter, you could have a butane that's all over the place and it could explode. Don't carry matches, flammable, combustible materials while welding, because that stuff can have an issue. Make sure your clothing is also in good condition as well. The stuff that we need for oxy-fuel welding is we need welding gases. We need a welding rod. You're going to have a welding rod that's going to be separate that you're going to feed in. Sometimes we need to have fluxes with certain welds. You're going to see some of that when we do brazing. And then we also need some fire brick to help maintain that heat within that weld. The acetylene is the most common gas that we use for oxy-fuel welding, but you do sometimes see hydrogen, you see propane, butane, and you also see natural gases within those systems as well. Propane is probably the next most common one that you see, but acetylene, it's the cheapest one, it's the easiest one to get, and that's why you see that most often. If we're doing some cutting operations, propane typically will get a good cut, a much cleaner cut, and so you'll see a lot of people that will use that. But the cost of it goes up significantly from acetylene, so that's why a lot of people stick with the acetylene there. We talked about check valves, and in these systems, there's a bunch of check valves that are in line with these systems. These check valves are designed, there's each one's for acetylene, there's ones for oxygen. These things essentially prevent the flow of gas in the reverse direction, so it allows flow in only one direction. Check valves will help make sure that if gases try to flow in the reverse direction, they will stop that and make sure that any flame that potentially might be in there aren't in there. When we talked about the reverse threads or left-handed threads on the acetylene, you can see the notches that I was talking about on this example. On the oxygen, there are no notches. These are standard right-handed threads to tighten those things up. The way a check valve works, and this is going to be very important because I'm going to ask this on the midterm. Check valves are a valve, but they're not like a valve that we're going to turn on or off. They work automatically. So we don't turn them off. We don't open them up. They're either going to be working if the pressure is going in one direction, or they will shut off if it's going the other direction. In this example, if you look on the left-hand side, if we have gas flowing from here, this is going to be from our tank to our torch body. This check valve has a little spring. It has a little valve disc that's going to seal. The pressure of that gas will push that spring, compress it down, and allow the gas to flow through. If the gas or the pressure comes too high from the other side, if we look at the right-hand side, if pressure starts coming down, that spring will extend back out, that disc will seal against there, and flow will stop. The gas will stop flowing at that point. So these check valves are really important to help stop any gases or flames from getting into a system. Flashback arresters are things that we have as well, and these things are in multiple places on our equipment. These flashback arresters are kind of like a check valve, but they actually have more things that will sense if a flame is traveling back up into there, that will then shut that off and prevent the flow of gas or flames from traveling further back. We have many of these things within our systems to help prevent that flame from potentially going all the way back into the tank if that does happen. On this torch body here that you can see, we could put a cutting torch, we could put a welding tip, we could put anything on the tip here. These things actually have flashback arresters that are built into both sides there. So that's going to help prevent that reverse of that flow there if something happens. And a lot of our systems are going to have these things. So if we happen to have a flame that comes back into there, okay, it can travel up into here. That flashback arrestor should stop it right here. The biggest thing, if we ever have a flashback, and you know a flashback because you're going to hear a loud pop, that's going to be a backfire, and then you're going to hear a very, very high-pitched whistle. That high-pitched whistle is the flame traveling back into the torch body and sucking in air to get the oxygen that that flame needs. So if we hear that high-pitched whistle, the best thing for us to do is to shut off our acetylene. That stuff will burn. Any acetylene in this torch body will burn out. The flame will go out. You can restart your torch. It's not going to cause any issues, any problems. If it happens to get passed into the hose, you may burn the hose up. But I have never seen that happen, and we have flashbacks that happen all the time. Okay, so that happens. It's very, very common. The best thing to do, shut off your acetylene, give it a couple seconds, it'll burn out. You can relight your torch and you can continue welding. The welding rod that we have is our filler metal that we're going to be using. In some cases, we are not going to be using filler metal, but most of the other welds on oxy-fuel, you're going to be using a welding rod. We are simply just going to be using mild steel, but you can do cast iron, stainless steel. We are going to do a little bit of braze welding. These are for welding alloys of different materials together. So we can actually combine a mild steel with like an aluminum, or a mild steel and a stainless, or a mild steel and a cast iron, or stainless and aluminum together. When we're braze welding, we're not actually melting the metal. We are simply heating it up and essentially gluing it by getting that braze material to weld into the pores there. We can do oxy-fuel with aluminum, although a lot of these systems, stainless steel and aluminum, is really done predominantly now with the use of TIG welding. Most of the time when we talk about oxy-fuel, we're working with mild steel. It's easy, it's cheap. That's kind of what we see. The welding rods are going to be similar to the ones that we see with sheet metal arc welding. The designations on them are going to be a little bit different, though. We have 3 different systems that we typically use: an RG45, an RG60, and an RG65. These things are going to relate to the tensile strength. So a 45 is going to be 45,000 pounds, a 60 is going to be 60,000 pounds, and a 105 is going to be 105,000 pounds of tensile strength. So they're not quite the same that we see with those systems. With sheet metal arc welding, they're not as laid out and, kind of systematic. Typically what we use in this class is just for a mild steel rod is just an RG45. So it's not going to be as strong as the sheet metal arc welding rods that we've been using, but on the thinner metal, strength isn't as big of an issue. Sometimes we do use a flux. A flux is a material that will help dissolve and melt, prevent oxides from going into there. If we're doing mild steel, we are not using fluxes. We use fluxes with silver alloys, copper alloys. If we're doing brazing, we're going to have a flux that's going to be on there. That flux is going to differentiate between what type of material we're actually welding on and the application that we have. The rods that we're going to be welding when we do braze welding is going to have a flux on the outside of the rod, much like your sheet metal arc welding stuff is going to have as well. So you don't have to worry about adding that in, but you have to use a rod that does have a flux to help prevent those oxides from getting in. Very often we use fire bricks. These are heat-resistant bricks. Okay, they are using refractory metals or materials to actually help retain that heat. These are not regular standard red bricks that you're going to buy from Home Depot or Lowe's. These are going to be bricks that are designed for like fireplaces, for barbecues, and for oxy-fuel welding. The bricks aren't going to pop, but they're going to help in maintaining the heat within a system, and they are not going to combust or catch on fire when we're doing them. So if you're welding with these things, using fire bricks is very, very important, not just standard red bricks. All the threads that we have on these things, we are going to create an airtight seal. The pipe joints are actually going to do that. Sometimes we have sealing compounds that we will use, and any gas lines, you actually can't just use a regular Teflon tape. You have to use a non-oil-based tape if you are going to do that. We apply them on the male threads, okay, and it helps make sure that other stuff doesn't get into that pipe. So the compounds, right, we need to make sure that we don't have oil within there. That could cause a fire. It could cause issues within that system. But most of the stuff that we have, the threads are actually going to seal without any use of sealing compound. And that is all we have for today.